Hi, good morning, good afternoon, or good evening, depending where you're dialing in from here today to this webinar. My name is Allan Klinge from Klinge Corporation, and I'm delighted to have with me as well Allan Kennedy from GDP UCI. We'll give a brief intro on ourselves here, but just wanted to thank you all for taking the time to join us here today. We're very excited to talk about the subject at hand, a rising tide, pharma takes to the seas. So just some quick housekeeping items, if I could. Please submit your questions throughout the webinar. Don't wait until the end. There's a Q&A box where you can just simply type your questions in, and we will try to take those kind of at the end of the session altogether to go through those with you. Anything related for this webinar and content will be available in this link, and there will be an available recording as well at the end of the webinar. If you do experience any issues with the platform, please go to the help icon and take it from there. So just a brief overview of myself and Allan here in terms of our roles. I'll talk a little bit more clearly about Klinge Corporation as a very quick intro, and then Allan will give some more information about GDP Universal Compliance Initiative. So today we're really going to focus on the shift that has been seen modally in the pharmaceutical market in terms of transport of product from air to ocean, and what may be driving some of those things. What are some of the challenges that have been faced? What are the benefits? And try to understand a little bit more about why the market has moved this way and where it is headed after. As I said, very quick intro. Klinge Corporation, we're based now in the US, but we're originally founded in Denmark, headquartered in York, Pennsylvania. We were the first company to introduce dual redundant refrigeration systems for transport of chemicals that would become highly dangerous if not cooled. So that is our long-term background, but more recently into the pharmaceutical space and customer-specific applications. That includes minus 60 Celsius systems, minus 70 Celsius storage applications, other military and other applications. For example, a specialty MRI system that we build where we cool a helium compressor down to 3 degrees above absolute zero for transport of MRI equipment around the world by ocean. Another application where we've seen a shift from the transport of the equipment from air to ocean. Again, just a very quick intro for myself, and I'll pass it off to Allan for his introduction.
Thank you, Allan. Good morning, good afternoon, good evening. As Allan just said to everyone, depending on where you are, my name is Allan Kennedy, and I'm based in the UK. For me, it's good afternoon. I'm here today alongside Allan with two L's to give the regulatory and compliance perspective on ocean freight for pharma. I'm also going to give you some details regarding sustainability considerations and the outlook for ocean freight going forward. But firstly, a little bit about the GDP UCI, the organization I represent. First of all, the safe and secure storage and transport of life and health critical pharma products is governed through compliance with official good distribution practice legislation, and this is issued by governments and their agencies. According to the European Medicines Agency, good distribution practice, or GDP, describes the minimum standards that a wholesale distributor must meet to ensure that quality and integrity of medicines is maintained throughout the supply chain. The GDP Universal Compliance Initiative, or GDP UCI for short, is a new cross-industry membership program that's applying evidence-based improvements to the medicine and vaccine distribution process in the pursuit of more efficient and harmonized GDP compliance. Amongst its goals, GDP UCI aims to introduce new concepts and systems for A, achieving, demonstrating, and recording GDP compliance, B, allowing the meaningful measurement of GDP for comparison, benchmarking, and continuous improvement purposes, and C, creating a more harmonized GDP training environment. Now, as a completely independent non-profit, GDP UCI is democratically governed with the membership open to all supply chain stakeholders of all types, all sizes, and in any location. By becoming a member of GDP UCI, companies become part of a transformative movement that advocates for enhanced compliance and best practices in pharmaceutical distribution. The interaction with a broad assemblage of supply chain experts not only benefits the member organisation, but also contributes to the industry's overall safety and efficiency.
So just to speak a little bit from a starting point of what a typical pharma cold chain looks like, we can certainly say there really isn't one, right? There's not a typical application that is always going to be the same across multiple platforms, across multiple delivery lanes, and across, of course, multiple jurisdictions or countries. But the main thing we can say that the only thing that's typical is that there is a high degree of regulatory oversight, a generally high value of the shipments, and of course, as I just mentioned, a very fragmented nature depending on where the product is going. So this fragmentation then leads, of course, to a high number of consignment touch points by different people during the transportation process. So there will be people, of course, producing the product, storing the product, packing the product, shipping the product, unpacking the product, and then, of course, all the way typically down to the end use application. But the most important feature, and one we'd like to stress today, related to what our discussion is focused on, is the extreme environmental sensitivity of many pharma products to heat or cold. So this is a very common issue that many of the manufacturers and partners in the supply chain are working through on a daily basis to try to make sure that stability budgets are met, that product is shipped properly, and that temperature excursions, of course, are avoided. The reasons, of course, being that temperature comprised product during that transportation wastes money and can also lead to severe health implications if the patients are presented with product that has not been properly transported. So not only are we working to save cargo value, we're of course mostly focused with the patient experience at the end of the day, and making sure that critical life-saving medicine is delivered at temperature. So one question we could ask for the group here, if everybody wouldn't mind just to respond within the application here. What percentage of pharmaceutical products do you think are currently transported in a temperature-managed environment? And I'll just give a few seconds here for folks to make their selections. So let's see what we have as a response here. So overwhelmingly responded less than 25% are currently transported in temperature managed environment. So let's take that as a discussion point. So slightly less than half are currently transported in temperature managed environment. So that is a little bit higher than the majority of the group thought, but certainly leads to then the second question of the challenges of transporting in those temperature managed environments. The cold chain, as we have been discussing, is not typical, but it is growing, and there are an emergence of highly temperature-sensitive biologic drugs, including classic biologic drugs like a vaccine, but also products such as gene-based therapies, recombinant proteins, stem cell treatments, and the like, all of which are driving this transition to a higher level of temperature management requirements. Let's try one more intro question here to just kind of get a sense of the team that's on the call currently. How much of your current pharma product moves by ocean? So 0%, 1 to 25, 26 to 50, more than 50, or I don't know. Yeah, I'll just give folks a quick few seconds here to make a reply, and we'll see what we get back in terms of the comments. Let's see what we have here as results. Whoops, I apologize. I believe the poll results are, I apologize, something seems to be going on with the application here. The poll results are not properly populating, but let's go right into the next comment where we're talking about how much pharma product is moving.
Okay, Alan, on the subject of modes of transport, let me just start by saying that air freight remains the dominant mode for the long distance transportation of pharma, and that's largely due to its speed. However, the increasing emphasis on sustainability, safety, and cost efficiency is leading to a growing adoption of sea freight, which now accounts for over 40% of pharma shipments. Multimodal transportation combining two or more freight modes is also gaining popularity for its flexibility and resilience. And note that road transport, although it accounts on its own for 20% of long-haul pharma freight, is more often than not utilised as a feeder service to connect manufacturing facilities with seaports, airports, and railheads. So it's a fact that few, if any, pharma shipments don't involve two or more different modes of transport and multimodal combinations. And these are growing fast as pharma companies regarding the scale of operation of container ships these days. I just wonder if anybody here in the audience has any thoughts about the equivalent standard wide body 777 Boeing and a 24,000 20-foot equivalent unit container ship. Would it be 200, 400, 600, or 800 aircraft? Cast your votes. Okay, quite evenly spread between, nobody thinks it's 200, but evenly spread between 400, 600, and 800. The actual answer is 800. Roughly 800 aircraft is the equivalent of just one 24,000 TEU container ship. So it just gives you an idea of the scale of capacity that these large ships have. And in fact, every single vaccine that was distributed during the pandemic, every single one distributed globally would have fitted on just 11 super container ships.
And to speak a little bit more about the containers that are going on the container vessels, we can just take a step back and say, what is a refrigerated container? This is the main means of transport for temperature controlled product, of course, on board of these large vessels, which Alan was mentioning, which keep getting bigger and bigger, to be honest. So every year it seems that they grow and somebody sets a new record for size of the vessel. And they are quite imposing if you've ever been next to one or close to one in actual proximity. These containers that are going on board, there's typically two types. There's a dry freight, and then there's a refrigerated container. Typically, these refrigerated containers are referred to reefer containers or refrigerated containers, whether or not they're doing temperatures or holding temperatures above or below freezing. Some people may use the word freezer every once in a while, but typically they're referred to as a reefer container, even if it's transporting something at minus 18 Celsius. The primary configurations are 20-foot or 40-foot. There's some very special applications at the 10-foot level, but primarily 40-foot is the main platform that is utilized in service these days. These systems consist typically of a condenser and evaporator section, as well as a control system, of course. And then these are typically plugged into the vessel ports, so into the vessel power ports, so that the unit will be plugged and running under power during the entire transport on the vessel. And when it comes off the vessel, it's plugged into the port power system. And typically when it's picked up by a truck, as Alan mentioned, road transport forming almost always a part of every transport. As you go to the feeder services, etc., the truck will typically have a chassis mounted generator set or some other power source to allow the reefer to be kept under power during final transport. Same with on the way to the port, of course. somewhat different, I think, than the way most people will think about air transport. All of these reefer containers are what we would call active reefer equipment. So these are all actively cooling using electric power. There is no real reliance on passive cooling systems, although sometimes we do see and do recommend for customers with incredibly temperature sensitive goods that they utilize even inside of the active reefer system, maybe some passive materials, PCM, other pallet covers, things like that, that can help with maintaining temperature of those products. Typically, also, they will come with some sort of remote monitoring system, and that is either a GSM-based system or a satellite-based system, or in some cases, it can be a combination of both, with the GSM taking the primary communication and the satellite taking a backup function. So just another question for the audience here to get a sense of what is the least important for you in terms of the pharmaceutical shipment. Wanted to kind of see where the focus is for the audience members here in terms of how they are valuing certain services there. Give a few seconds here. And let's see what kind of responses we have. Which of these factors are the least important? So speed and time efficiency does come up as a response, which is pretty interesting. Carbon footprint and sustainability also. So those are actually some pretty interesting responses that we'll be able to parse through here in some of the upcoming conversation. As we talk about the benefits of ocean freight over air freight, the main benefit of air transport most companies are considering is speed. And speed means there are certain tracking items that come into play, but also it is thought of as a risk mitigation strategy by getting a product somewhere faster. So as we talk about temperature excursions in air transport versus ocean transport, as we speak about the ways in which we look at risk over the transit, as we speak about the ways in which we look at additional safety measures that can be put in place, these all are ways of certainly making a longer transit safer, but it will never be as fast, of course, to ship by ocean as it will be to ship by air. So there are some trade-offs that we need to discuss, of course, during this webinar here. As we talked about before, companies are really focused on these very temperature sensitive goods and finding a effective and safe method of transport. Oftentimes that means that they are looking for more stable methods of transport, and that can be as simple as the number of times the container, whether it's a smaller container being shipped on an airplane or an ocean going container, are opened and looked at by customs officials, or how many times that the container may be subject to higher heat and higher temperature environments during that transit. So there are many mitigating things that we can do for those challenges. In these cases of air transport, speed tends to be subordinate to safety, and risk is increased during the temperature excursions that can occur during air freight. So there may be limited amount of time, for example, that a passive system can maintain temperature, because the assumption is that nothing will go wrong and that speed is more important than getting the product there in a stable manner. Simply understood, we know that most companies who have been looking and making transition to ocean freight have seen fewer temperature excursions in their products, have seen less product waste, less additional quality studies needed, etc. And of course, we want to talk about the environmental impact of air freight. Typically, it is more expensive, and it does come with a high environmental impact.
Okay, so I'll just continue on that topic with respect to sustainability. Sustainability is rapidly becoming the single biggest motivation for ocean freight as companies start to wake up to the realities of environmental degradation and the need for global sustainability. And by any objective measure, ocean freight per ton kilometer has a microscopic carbon footprint compared to the equivalent air freight. To give you an example, the CO2 emissions of air freight can be as much as 2,000 grams per ton kilometre, compared to the latest generation of container ships, where it can be as low as 8 grams per ton kilometre. And another way of looking at this is to be aware that ocean freight, in transporting nearly 80% of all global cargo, emits almost exactly the same volume of greenhouse gases that air freight does in transporting less than 1/4% of global cargo. And take it from me, no matter what you might read in the press, a world with viable electric or hydrogen-powered freighter planes is quite simply decades away. So with the overall transportation sector contributing over 25% of global CO2 emissions, there's a global push towards carbon reduction, with initiatives like the European Green Deal aiming to reduce transport emissions significantly. Note that of this 25% of CO2 from transport, around 40% relates to freight. And this means that freight alone accounts for a staggering 10% of all CO2 emissions. 10% of all global CO2 emissions come from freight. Now, for pharmaceutical companies, modal shifts from air to ocean freight can play an important role in achieving their sustainability targets. In particular, GDP-compliant pharma eco-lanes within green freight corridors provide a potential avenue for environmentally friendly pharma distribution. Such integrated eco-lanes will link up the main pharma production centres and distribution hubs in alignment with international sustainability policies. And here at GDP UCI, a product has just commenced to explore the potential of and appetite for just such solutions.
Similarly to what Allan was speaking about, a recent project optimized study, a collaboration between WHO and PATH, found that using ocean reefers is less expensive than actively or passively cooled air transport options, even when only a quarter of a 20-foot container is utilized. So you can talk about the cost savings, of course, on top of the sustainability savings. We have heard this position related to cost reduction reinforced a number of times throughout industry conference presentations, and I'll be frank, we've heard many even better stories about those cost savings and how they're realized. So there was a recent interview as well with AstraZeneca. We're here in Pharma in Boston. Actually, they had noted 65% of their product was moving by ocean, although they were closer to 70 as well in a recent presentation. Merck has noted that in mid-2023 at another conference, they're moving about an average of 50% of their volume by ocean. And in that case, Merck specifically also noted the large amount of cost savings that were being realized, as I mentioned before, in terms of product quality, so not having to discard quality on arrival, the actual cost, of course, of the freight, as we're mentioning here as well, and of course, the fact that they don't have to do as many quality analyses and studies, just this sheer expense of having to review all of those reams and reams of data that I'm sure many are familiar with in this industry, when something does go wrong, when there is a temperature excursion. So avoiding those three cost drivers has really allowed these companies to save, in some cases, millions of dollars in their transport and supply chains, while also focusing on that reduction in carbon footprint that Allan was discussing here just before. I will say that this process and these projects and these transitions, they don't happen overnight. They require a great deal of trust between the various partners that are involved in the process. And the overwhelming feeling is that if you have good partners, this is very doable, but it does take time, it does take effort. It takes certain SLAs or service level agreements, SOPs, standard operating procedures, to achieve success in these matters and to realize these cost savings. But at the end of the day, after the work has been done, for the most part, we have found very, very positive responses from industry in terms of how they have then made this move and the good success that they've had in making that move from both a cost and a product safety and a carbon footprint perspective. So one thing I mentioned was we talked about the number of handoffs and people who may be opening or packing or looking at product during a transit. Typically for a container shipment, if you're loading a full container and shipping it across the ocean, there is no opening of that container, and there's a custom seal on the container itself to make sure that it does not get opened until it reaches its final location. So this kind of active cooling process without the interruption of let's say interested parties who may decide that it's worth taking a look inside this package does offer a very high level of temperature stability, and that is certainly something we've heard reflected in comments from industry as well. There are a few challenges in the ocean freight industry. Of course, there is a longer shipment time. There is a lot of schedule volatility, as many of you will, I'm sure, remember during the pandemic in particular, and immediately following coming out of the pandemic. There is also there's also need for increased planning and a floating inventory, if you will, which we can get into more detail on later, where you do have to have, let's say, if it's a 6-week travel, you're going to have to carry 6 weeks worth more of inventory. But just something to point out about that process too is if you have planning done to the point where you can more or less understand that need for those 6 weeks of inventory being at a location 6 weeks from now, it does give some flexibility also to meet any urgent product demands by air transport if you did have to also send other product somewhere else. So we were recently in a discussion in Lyon last year where that was mentioned by one of the panel members as saying the floating inventory, it is certainly an investment, but it does give you a lot of options for expediting product by air that you wouldn't otherwise possibly have, where you'd be sending everything by air at the same time as well. And of course, there's a need for a universal good distribution practice strategy that can be applied seamlessly across multiple countries and jurisdictions, something that Allan and his team are focused very highly on, allowing for the success of that kind of implementation of those GDP strategies. Just to kind of touch on this again, most applications of ocean air also have multimodal aspects. This was what Allan was mentioning with the handoffs in between rail and ocean, or ocean and road transport as well. And even, of course, everything that goes by air typically is touched by road transport at some point. So there's no one here who's suggesting one single mode of transport will be the solution for all products. There are a number of products that are still moving by air, of course, and sometimes there are products that we can't really move by air that need to be moved by ocean. And even there, I might be speaking of certain aerosolized products that are much easier to move by ocean, for example, that might have some dangerous goods components to it versus shipping them on the planes. But there is also a product-based evaluation that's going on with every single product to say this is the best shipping method for me, and no one here is saying there's only one method to do it. For example, we also have a lot of the -70 Celsius products, of course, that are floating around the world here, even down lower than that. But sometimes there is a demand there for some dual redundancy in the shipping process, meaning you have a backup system that will automatically take over, or you might have power generation built into the reefer containers themselves. And that's some of the applications that Klinge, for example, does on a very specialized product basis. So there are solutions out there for everybody, and we are here just to try to present a few that may not be as well known in terms of the ocean freight applications. So one thing that everybody, I'm sure, has had some interesting experience with is how the pandemic may have impacted global pharma freight operations. And in some ways, we'll talk about how pandemic accelerated certain things, or how it made other things more complicated, how it made some things maybe easier because there was a bigger investment in doing things a different way. So if you would just give a quick comment here, if you had positive, negative, or no significant impact in terms of how the COVID-19 pandemic affected your perception of global pharma freight operations. Okay, so 87.5% say it was a positive impact, which is great to hear. First of all, that means everybody learned a lot during the process, so that's always good. And glad to hear it was not negative for so many of the group. So I
Okay,
think
thank you, Alan. I'll take over on that. Sorry?
Yeah, go ahead. Sorry.
I was just going to say that the reason people are very positive about it is because of the way that the industry rallied together when the chips were down to actually make sure vaccines were distributed across the planet as quickly as possible. But other than that, I have to say that pharmaceutical logistics as an entity has been affected both negatively as well as positively by the pandemic, depending on the perspective. So I'll start with the positives by saying that until the pandemic focused global attention on vaccine distribution, you could say that logistics was the 800-pound gorilla in the room that everyone pretended not to see. We've all seen, however, that the COVID-19 crisis has created a recognition of the vital contribution that effective transportation can make to a successful vaccination programme. And we've also witnessed the importance of cross-industry and inter-industry collaboration, where companies and individuals work together to address industry-wide problems and change industry priorities. So if there are any silver linings to the pandemic cloud, one of them is that it has proved to be an enormous catalyst for change, forcing revisions in perspective and accelerating essential modernisation and reform. The pandemic disruptions also highlighted the critical importance of resilience, as Alan's been saying, and this has resulted in an appreciation of the need for alternative logistics routes and for multimodal freight strategies. Back in 2020, these changes were no more than a knee-jerk as shippers desperately tried to get their product to market. But now the changes are at the forefront of policy as shippers seek new ways of future-proofing their freight policies. Other welcome knock-on effects from the disruptions that took place include an acceleration of digital control and visibility solutions due to the need to monitor sensitive vaccine shipments closely during transport. And this is something Alan will have a lot more to say on. Another pandemic premium relates to an increase in investment. During and since the pandemic, a lot of new money has been invested in refrigerated transport and storage infrastructure. Although I do need to emphasize that for some developing countries, the pandemic led to economic downturn, which sadly has had the opposite effect. Finally, it's fair to say that some of these legacy pandemic transformations have proved instrumental in minimizing the effects of more recent large-scale logistics disruptions, such as the Ukraine war, of course, and the current Suez and Panama Canal crises. As well as the huge turmoil caused at the time, there are legacy downsides from the pandemic. One of the negatives relates to an increase in inventory costs, as Alan was explaining, as companies hold more stock and rely less on JIT, just-in-time replenishments. Another consequence is the longer-term trend of onshoring and nearshoring, in which shippers seek to reduce their dependency on remote supplies by moving production closer to home. This is a trend that will undoubtedly have implications for pharma freight patterns in the future. And there are other consequences which are good or bad depending on your perspective. For example, the pandemic-induced escalation of freight rates proved to be a massive windfall for those ocean carriers that were able to manipulate severe capacity shortages to their advantage. Many shipping lines recorded their greatest ever profits when the pandemic was at its height. In fact, in 2021, the collective total profit of the global carriers reached no less than $150 billion, by far the highest on record. But as things get back to normal, and as recessionary signals appear on the horizon, we've seen ocean freight rates tumbling quite sharply in many trade lanes. However, not before the industry managed to place a record order book for more ships, in fact, 30% more ships, in order to take advantage of the record rates. So when these gleaming new vessels come on stream in a year or so, some shipping lines are in for a very hard landing indeed, which could be good news for shippers of pharmaceutical and other products.
So we wanted to ask you as well,
Sorry.
from a quality assurance perspective, what do you see as the main obstacle in moving freight by sea? So what might be some of the challenges that the team here or the members on the webinar might think are the most difficult things to overcome when moving freight by sea? Let's see what we've got as responses here. So temperature control is not one of them, but regulatory compliance, supply chain incompetence, lack of flexibility, and insurance. Okay. Yeah, very interesting responses. So I will say from the industry side, I think the responses that I have primarily heard have been around temperature control and regulatory compliance. So I will hand this off to Allan here and let him talk about some of these quality obstacles.
Okay, thanks, Alan. Yes, I would like to say a few words about the quality and regulatory requirements of shipping pharma, particularly by sea. So let me start by saying that the legislation governing the safe and secure shipment of pharmaceuticals, in other words, the quality of distribution, is, as I mentioned earlier, generally enshrined in what is called good distribution practice, or GDP. GDP, however, is very generic and non-prescriptive in nature. So basically, the law essentially tells you what you must achieve, but not how to achieve it. Furthermore, the very same GDP rules apply to all modes of transport: air, ocean, road, and rail. However, in practice, these are all very different transport systems, meaning that the regulations have to be interpreted and adapted to suit the mode concerned. This creates huge problems because different parties and different nations interpret, execute, and enforce the regulations in different ways and to different standards. And complicating matters even further is the fact that GDP legislation varies around the world, with different jurisdictions and political unions adhering to different rules and employing differing standards of auditing and enforcement. This all makes for a very complex and inefficient quality process, especially as pharma products are becoming more complex and sensitive, and supply chains are becoming more global and more multimodal. Although there have been attempts to bring some sense and uniformity to regulatory compliance, for example, the CEIV certification scheme from IATA, it's abundantly clear from research and feedback that supply chain confusion and impediments concerning GDP remain. There is a pressing need for an industry-driven GDP support framework that covers all freight modes, is global in scope, is supported by regulatory bodies, and is adaptable to changing industry and regulatory needs. Such a framework is particularly needed for pharma ocean freight, where clear-cut GDP guidelines would undoubtedly drive more pharma business into its hands. It's this persistent supply chain confusion that has led to the GDP Universal Compliance Initiative being established by a group of pharmaceutical supply chain stakeholders. The GDP UCI, as you've seen, is a non-profit that works in collaboration with the industry to introduce GDP compliant processes and solutions, and to synchronize and harmonize GDP training, auditing, and certification, all contributing to a more cohesive and effective quality framework. Such a global multimodal framework is essential for overcoming the mounting complexities of quality assurance in the evolving pharmaceutical supply chain.
Thank you, Allan, for speaking to those points. And I will just touch base on what Allan had mentioned a little bit earlier about the growing development of digital management of the shipment visibility, especially as it relates currently to ocean freight as well. So there is a continued and constant demand, of course, for product data as it's moving through the supply chain to make sure that the temperature excursions are not occurring, and when they do, for how long they may occur, and at what temperature ranges the product is exposed. But this has also become very critical for real-time data transmission on ocean freight, where the product may be out of sight, so to speak, for longer, of course, than an air freight transport. So there is a demand for not only data loggers such as temp tails to be in the product or on the packaging or on a pallet, let's say, but also for a real-time transmission of data during the transit. This data most typically, as we talked about earlier, comes directly from the refrigeration unit itself. So we're talking about providing data of certain points inside the container where the product is being shipped, typically in a palletized form within further boxes and packaging. This kind of data can give some indication to when there may be an issue or a longer power off time than would be desired, and give kind of that pre-indicative information to someone that they can take some action and resolve it. The main platform, as I mentioned, is GSM, with a number of smart reefers having GSM applications built directly into the reefer system themselves. That information can typically either be communicated once in network, or on some vessels they're equipped with GSM devices as well. Pardon me. The GSM devices on the vessels. I apologize. Sorry. It's winter time, so the GSM devices on the vessels are being communicated with via a certain network, and can then broadcast information out over a satellite connection. The satellite connections can also be directly installed on the equipment, and if they are, they can be broadcasting information directly from the vessel itself. Sorry. So once we do have the data, what do we do with it? The main focus here has been on moving to a predictive analytics to see where we can look at supply chain lanes and determine where there may be some difficulties coming up, some temperature deviations that are typical in a given season, or trying to then also predict where there may be failure points with certain handoffs and applications. But the main issue is trying to make that a universal approach while also dealing with issues such as battery life. Most problems are being tackled by individual companies, and if we can get to a universal application, including some universal communication protocols on the vessels themselves, then I think we can come up with a very good solution for this kind of monitoring. Again, I apologize for my voice here. Alan, would you mind taking this one?
Yes, this question is all about change. What do you consider the biggest change that is likely in the pharma cold chain in the next 5 years based on the discussions? Significant growth in consumption, increased modal flexibility, greater environmental concerns, technical innovation, or something else? Cast your votes. And right at the top of the pile, significant growth in consumption, which is very interesting. So let's just have a look at some of these factors here, because I'm going to look at what we can expect over the next 5 years. And first of all, I'll say that over the coming years, pharma logistics will continue on its path of transformation. There's a lot going on at the moment, and this is going to continue. But it's going to be fueled by a strong growth, just as the voters have just said, in pharma consumption, suggesting an increasing demand for temperature-controlled logistics. Although globalization and mega-scale manufacturing plants may become less of a priority for manufacturers, there's no doubt that the global consumption of drugs will continue to expand significantly, with cold chain products expected to represent more than 70% of total logistics spend. Other changes will include increasing modal flexibility, as we keep saying, from shippers in response to increasing uncertainty. As we've seen, the post-pandemic logistics strategies of pharma companies are strongly emphasizing resilience and agility as they seek to avoid overdependence on any single mode of transportation. And over the next 5 years, the environmental imperative will play an ever more pivotal role, in shaping technical, operational, and commercial decisions as the global sustainability agenda gathers pace, driven by increasingly aggressive emission reduction strategies from governments. And from an operational perspective, innovative inventory solutions such as floating warehouses, which Allan touched upon, will be crucial in ensuring reliable medicine distribution. And the pharma supply chain will benefit from better planning and scenario analysis, with digital modeling, forecasting, and early warning systems having big roles to play. And as Allan has just explained, real-time consignment surveillance with preemptive and diagnostic capabilities will become the norm as digital systems improve and become more affordable. And in terms of transport modes, in recent years, the industry has relied heavily on air freight on the basis that it is fast, flexible, and pharma-friendly. But at the same time, it's expensive, unsatisfactory from an environmental perspective, and has an inferior product safety record. So we can expect the trend towards sea freight to continue. Finally, it's worth noting that the pandemic exposed some huge, yet until then practically unimaginable flaws in the respective business cases of both air freight and sea freight. In the case of air freight, it was its susceptibility to very abrupt and prolonged contraction in the face of any disruption that affects its core passenger transport business, its PAX business. In the case of sea freight, it was a challenge of synchronizing the availability of container stock and avoiding severe cargo bottlenecks. So going forward, pharma companies are going to remain very cautious about putting all their pharma eggs in any one modal basket. In conclusion, the future of the pharma cold chain over the next half-decade promises solid growth, increasing modal resilience, improved regulatory conformance, and exciting technical innovations. The projected growth of global drug consumption at approximately 5% annually signifies a robust pharma logistics sector with therapies, especially biologics, that require cold chain capabilities expected to grow by nearly 50%. Nonetheless, the pharma industry faces some very serious challenges in meeting this demand, while at the same time ensuring safe and efficient transportation of pharma. It will navigate these stormy waters through collaborative initiatives, sustainable practices, improved GDP, and advancements in technology. As the pharma landscape continues to evolve rapidly, teamwork, adaptability, and a forward-looking approach will be essential for both pharmaceutical companies and their logistics partners.
Yeah, thank you, Alan. Sorry again, my cough did not agree with the timing of this webinar, apparently. So what makes our refrigerated transport containers so specialized in terms of the Klinge systems? Just to give a small background, that we do dual redundant applications, typically between 0 to plus 25 or down all the way to minus 70 Celsius. They have typically built-in backup generator application, as well as special relationships with the shipping lines themselves, and also this onboard tracking that we have that we've been discussing in terms of visibility on the vessel. I know there's a few questions that have popped up on the Q&A related to that, so I will make sure we handle those. Again, the systems that we're providing here are made to ensure that even if there were some issue during transport, you have a backup system that's ready to go. And it's an important part of the safety net that we can build into these transport applications as companies are looking to transition from the air applications to the ocean applications, where there is a feeling of security and safety on board the vessels. And this is tied directly into the remote monitoring applications, where you can see even on a small screenshot here that you can actually get communication from the vessels directly, in terms of the satellite communications coming out, but also, of course, intense coverage when it's in network for GSM as well. And with that, I think we are just about 10 minutes left for Q&A, Alan, so we'll try to go through some of the questions that have come up. So the first one was, do the generators for road rail power act as backup while on the sea? Are there risks of power outages on the ships? So the systems that we build do have an integral genset that can be shipped or is then shipped with the container. It's inside of what we call the ISO envelope, the container envelope. Typical applications for reefer, though, don't include a generator that's built into the container, so they are typically only mounted on the truck or the chassis. The power on the vessels, though, is very, very dependable. So in all the years that we've had integral gensets on our equipment, for example, I think there's only been one time where they've had to turn on a generator set on the vessel, and it was only temporarily during what they called a brownout sort of situation from the main engine. So because the power is being supplied to the main engine and then from there taken to power the reefer equipment on the vessel, there's a very, very low risk of that main engine not functioning properly. So let's see.
Yeah, I'll just add that I agree that it's a very, very rare occurrence at sea. When it does happen, it tends to be very short duration. I mean, I've seen it happen during storm events, very short period. But the thermal flywheel effect of an insulated reefer with bulk contents is almost unaffected. You know, we have data to show what happens in those circumstances, and it almost negligible in terms of impact on the reefer contents. As I say, we've got data for that.
There was another question here. Are the qualification validation documents available for reefer container performance that show the ability for active system to maintain control? Is each unit qualified? Are there any recertifications done yearly, etc.? So the answer to that, typically, I would say on most reefer transport lanes, is that there is a initial qualification validation done of a particular type of equipment. But usually that specific container, for example, just like when you qualify a specific lane for shipment via truck, that specific container is not the same one that you will get next time, but you will get the same type of container. There can be requirements for recalibration or recertifications that can be done, but typically they're not done in that way. There's typically maybe an additional temperature mapping done on an annual basis of that specific container type or product type, but it is not in the same way that a specific individual warehouse, for example, would be done. And a lot of that is also too because of the additional packaging and measures that are taken inside of the reefer container. And it's kind of important to remember that the cost savings are so large in terms of the movement from air to ocean that there is, of course, some room for adding additional PCM or other packaging or other safety measures inside of the container to help offset any sort of risk. So that is something that should be thought of and should be a point of discussion among folks making the transition. Another question, and if we don't get all the questions, we'll be sure to actually answer them after as well. So go ahead, Alan.
I'm just going to say that in reality, the real area of risk, if there is one with ocean freight, is the possibility of a door open event for whatever reasons, and it can very, very occasionally happen in a customs inspection situation. Even without warning in some cases, at least in Europe. So that's where you would need secondary protection. In other words, you would need to have some extra protection for the contents of the reefer. But in almost all cases, the reefer remains closed for the duration of the voyage from start to finish, from factory gate to factory gate. So it's a very safe mode. But in terms of the qualification documentation, this would all form part of the protocols for each lane validation. So that would define whether it was deemed necessary to revalidate on an annual basis, requalify, etc., or whatever interval. There are no set standard procedures for that at this point in time.
So there was a question, should all vessels have private GSM networks for containers to connect? So there is a movement going on now for a communication protocol, as I mentioned, across industry in terms of the carriers. In the past, they would use power line monitoring for temperatures, for example, in the containers. So as a wireless protocol, that is something that is slowly moving forward. But what we have done in our applications in any case is we do have the GSM connection capability, but we build in the satellite function just so we have a backup. And even if you were to then move between vessels, for example, if there's a transshipment, you could still have that connection to some satellite data during the voyage. So right now it's slowly moving toward a little bit more uniformity on board the vessels, but there are also a lot of vessels depending on where you're going from different carriers. And we're trying, we're working to get everyone on the same page, but for now we've built that possibility directly into the system. So let's see here. There was a few comments about lost the connection and whether there'll be a recording. Yes, unfortunately for my voice, it'll be recorded for posterity and they'll be available to everyone. So that will be able to be sent out after. So hopefully some of these questions I think we'll be answering also in written form if people really lost the full connection. Do the liners allow working backup on their vessels? So I will say that gensets are not really operated on the vessels typically. The diesel fuel that's on there, though, is not considered DG when it's powering one of these reefer units. It's under that allowable limit. So it is something that does go as part of the container, not as a separately declared dangerous good. How about this one, Alan, for you, maybe? Is the expected growth in ocean freight volumes also linked with the dramatic population growth? Is that anything you have a comment on, Alan?
I don't know about specifically ocean volumes in terms of medicines, but the pharma consumption is growing very rapidly, and it's not just population growth. It's the fact that countries are aspiring to the levels of pharma consumption that you have in the States, for example, which far exceeds that even in Europe. So there's a long way to go for pharma growth as sort of emerging economies and so on start to get health systems which rely on huge amounts of drugs and pharmas and vaccines. So I don't know how much population growth impacts the growth in ocean freight. I think factors such as the rise in generic manufacturing, which tends to use a lot of ocean freight because of the volumes concerned and because of the lower cost of such products, where it's more cost effective to send by ocean. I think these are the factors which are really driving drugs onto the ocean. But the biggest factor on its own is, as I said earlier, sustainability. People must start to take action on sustainability issues because they're being mandated increasingly to do so, and it's going to be something which you can't escape from. We must become a much more greener industry. Farmers, logistics, a very poor track record in terms of its carbon footprint, and that will have to be improved in the coming years very quickly.
And I see there's a few questions here I'll try to tackle because we're just about time around the data that's being logged or collected during the voyage. So if you're booking with a specific carrier, they should be sharing that data with you directly. Often it's not 100% live, but sometimes they will give you access to it more live than not. The data is then usually available from their server, and they will make access for certain customers. With our systems as well, we would have a portal where you'd go to access the data and download the data for historical purposes. The types of data, again, would be temperatures in the container, any sort of alarm conditions, location, those sorts of things. The average unplugged time for reefers is another question I see on here. That can vary, as is noted here, drastically from port to port. Typically, the most common application we see is that somebody is signing an SLA with the carrier, who then will flow that down through the terminal and the logistics partners to say this is the maximum time that the container can be unplugged. And they will set up certain protocols for alarm conditions and things like that, well before you hit that maximum time, of course. But so that there can be people that can intercede. And we see a lot of that work with the logistics partners as well to help avoid those issues. So it is dependent on the port, and I would say it's very important to work on certain lanes first, your larger lanes first. We know there's excellent service, for example, in Singapore and Antwerp, provided by PSA and the terminals there for minimizing those sorts of unplugged times. There's lots of shipping lines that are promising very short unplugged times as well. So it's just really about that trust and that partnership that we talked about earlier in the webinar. I think we've actually answered all the questions, and we're still on 11 o'clock. Alan, what do you say?
Yeah, I think we've just about bang on in terms of the time. So I think we've done very well. But if there are any questions that anyone wants answered, they can continue to submit them, and they will get answered. We will get back to everyone who submits a question.
Yeah, great. Well, so I would like to thank everyone for joining us, and especially for Alan being here as well. I again apologize about my voice there for a little bit, but we'll look forward to having any more questions and any other thoughts. And Alan, if you had a final comment.
No, just it's been a great session. Thanks for having me on this particular webinar, because it's a very interesting topic. I think there's a lot to learn from your experience and so on. And I just hope we can build on this maybe in future webinars, future sessions.
Thank you very much, everyone, and take care.
Thank you.